All right, this is learning target 6.2. It's on multiplying polynomials. Now, a lot of this section was review from Unit 3, so I'm going to go over a lot of these problems really quickly. I already have my answers shown, but if you need more support or additional examples, take a look at the videos from Unit 3, Standard 3. So, Unit 3, Standard 3 will definitely give you more examples if you need more help with this. So number 7, I want you to focus on that one. It's a one term multiplied by a binomial. I'm going to do the distributed property here, and I multiply my coefficients. So 3 times 2 is 6, x squared y is my solution. 3x squared times 5x will give us a 15x to the third power. You add your exponents when you have the same base. Number 8. It's a 3 by 2, so I would multiply using like the rectangle method. You create your rectangle, your 3 by 2 box, and you put your terms 3x minus 2, 2x squared plus 3x minus 1, and then you multiply each individual part to fill in the box. Then once you get your solutions, combine like terms, so whatever have the same variable with the same exponent, then we connect those. So our final answer is 6x to the third plus 5x squared minus 9x plus 2. Number 9, I gave you an example, or showed you, you could do the box method, but I did FOIL in this one. So we take first times first, which is a times 4ab, which gives us 4a squared b. Outer, we get a times b squared, which is ab squared. Inner, we get 8ab squared. And then last, 2b cubed. Remember to combine like terms just like you would in the box method. And then this is our final answer, 4a squared b plus 9ab squared plus 2b to the third power. Okay, so I want to focus on Pascal's triangle. That's a new topic that we haven't really gone over until this unit. So I drew out my Pascal's triangle here. Starts with ones. Ones are on the outside. And then notice to get your term, you always add the 2 previous in front of it. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, so on, and you create your Pascal's triangle. The rows start at 0, and it goes 1, 2, 3, 4, 5. Notice the second term here is similar. That might help you when you decide which one's which. So let's take a look at number 10. Number 10, we want to figure out what x plus 3 squared is. One option you could do, you could expand that and rewrite it as x plus 3, x plus 3. You could do FOIL, you could do the box method, but what I want to show you, Pascal's triangle with this example. So we have this x plus 3, and we're taking it to the second power, that whole quantity. Well, what you can do is you can go to the second row, 1, 2, 1, and use that as your leading coefficients in the problem. So 1, 2, 1. So what I'm going to do, I'm going to list those here. 1 times, I'm going to leave it a blank for now. I'll show you what I'm going to fill in later. 2 and 1. Those are my leading coefficients, 1, 2, 1. Okay, now what goes next? You're going to take your first term x, and you're going to write that here, x, and you're going to take it to the second power, because we're going to start high to low. So I'm going to go to the second power, and then I'm going to multiply my second one. I'm going to take that to the first power, and then I'm going to go x to the 0 power. Notice how I'm going in descending order. It went from 2, 1, 0. Okay, now I'm going to take my second term, 3, and I'm going to go low to high. I'm going to take 0, take that to the 0 power, 3 to the first power, and 3 to the second power. So I just went from low to high, 0, 1, 2. It ends at 2 because that's what power I'm going to get. Okay, now the next part of the problem, we want to simplify our solution. So we calculate 1 times x squared. 3 to the 0 is just 1, so that's going to cancel. So we're going to get x squared as our first part. 3 to the first is 3 times 2. We get 6x plus x to the 0, that cancels, that's just 1. 3 squared is 9 times 1, we get plus 9. So that's our answer. And you can test it by FOILing. X times x is x squared, x times 3 is 3x, 3 times x is 3x, 3 times 3 is 9. So we do get the same solution if we combine like terms, x squared plus 6x plus 9. So it does work out. Okay, I want to show you one with a little bit more complicated problem, like number 12. We're going to take it to the 5th power here. So I'm going to go to my 5th row and use those as my leading coefficients. So you can start that out. Go 1 times, I'm going to put kind of blanks or brackets around these so it helps me distinguish between them. Plus 10 times plus 5 plus 1. Okay, so I have my leading coefficients. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. All right, now I'm going to take my first term, x, and I'm going to go in descending order starting at 5. So I'm going to go x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Then I'm going to take my -4, it's technically a -4, and I'm going to take that and start low to high. So I start at 0, and I go all the way up, and go in ascending order. So -4 squared, -4 to the 3rd, -4 to the 4th, -4 to the 5th. All right, next I need to simplify each part. So I have all my work. Now I just need to simplify it and come up with my polynomial. So I can start off with this x to the 5th, -4 to the 0. Well, -4 to the 0 is just 1, so we can cancel it off. We're left with x to the 5th power. Now let's move on to our next one. We're going to get -4 to the 1st power. Well, that's going to equal -4. And then we multiply it by 5. So it's going to actually be a -20. We can erase that plus sign and write minus 20x to the 4th. Notice how we're going to start to go in descending order with our variables. Next part, we do exponent first. -4 squared is 16. 16 times 10 is 160. X to the 3rd. We include our x to the 3rd. -4 to the 3rd power is going to equal -64. -64 times 10 is a -640 x to the 2nd power. And then move on. -4 to the 4th, that will be 256 times 5. We get 1,280 times x. X to the 0 cancels, so we're left with -4 to the 5th, which is a -1,024. And then that's it. That's your solution. Notice how it goes in descending order. So it's in standard form, x to the 5th, 4th, 3rd, 2nd, 1st, and then 0. We have all our work, and that is how we solve using Pascal's triangle. All right, I want to quickly go over number 13, that one. I just showed you the answer, but you're finding the volume of a rectangular prism. So how you find volume is you go length times width times depth. What I would recommend doing is multiply this monomial first. Take your monomial, multiply by one of the lengths. Let's go 5x, or 2x times 5x plus 3. Since it's just a monomial multiplied by a binomial, do the distributive property. And just do it to your first term. So you get 10x squared, 2x times 3 is 6x. Then take that binomial and multiply it by your leftover x minus 6. I did the box method here. So you take 10x squared plus 6x, multiply by 6, or x minus 6. You multiply your values, combine like terms, we end up getting 10x to the third minus 54x squared minus 36. And that is the end of 6-2. Basically, some of this is review. The big part is Pascal's triangle. Make sure you know Pascal's triangle and how to simplify each part.